let's do the review for your exam 2, right? For chapter 10, what we have been learning? We learned the graphs, right? For what? For two things we were doing. One is exponential functions, right? Another one is what? Log functions. So we are going to visualize it to know the concepts. Then next thing we will learn is what? We have learned is composite functions, also inverse functions, right? Then what else we have learned? Then we learned how to solve equations, right? Solve equations for both of them. Then we do some apps. So that will be in your exams, in the exam 2, right? Okay. So your test will be like this for the graphs. So if we have y equals 4x minus 3, one is what? Exponential function. Another one is f of x equals log base 4 instead of base 2 we had in the class, right? So they are not the inverse to each other for these two, because this inverse will be what? This is y equals log 4 of x, then inverse will be what? X, should be y equals 4 to the x power, right? 4 to the y equals x, or 4 to the x equals y for the inverse. So the graphs are a little bit different. If it's different, what should you do? Do the t-table always, right? So this t-table would be, look like what? What kind of points you should use? Y equals 4x minus 3 for exponential functions. We put a 0 in the middle, 1, 2, negative 1, negative 2. All right, give 5 points. So 4 to the 0 is what? 1 minus 3, right? So it's negative 2. Then this one is 4 to the 1 power minus 3. It would be 1. 4 to the second power, 16 minus 3 would be what? 13. Then 4 to the negative 1 power minus 3. 4 to the negative 1 is what? 1/4, right? Minus 3 would be what? Negative 2 3/4, right? Then 4 to the negative 2 power minus 3 is what? 1 to the 4 to the second power is 1/16 minus 3 is what? Negative 2 15/16, right? Getting close to the negative 3, right? So what should we have? We have 1, 2, 3. Okay, so it should be limited by this line, because you know, for regular 2 to the x power, 3 to the x power, right? It's like this. Then minus 3, everything shift down 3. It was limited by this line, y equals 0. So you shift down 3 points, right? 3 units. That would be to be bounded by this line, right? So 0 is negative 2, then 1 is 1, okay, 2 is up there. So then negative 1 would be here, -1, -2 3/4, right? The next one is getting close to this line. That would be -2 and -2, 15 and 16, right? Right here. So your curve would be like this. Then it's getting close. When you graph on the test, when you graph the line, don't go over y equals 3, right? Because it's bounded by. So this is just your regular exponential function, but shift down 3. So if we ask you what's the domain, left and right for x, what's your range, up and down, all the way up, but limited by -3, but never touch, oops, that should be -3, right? That should be -3. So what else? We will ask you what's the x-intercept and y-intercept. What do you think? X-intercept is right there, right here, right? But not 1, not 0, 1. What's your y-intercept? You know y-intercept right here. X is 0, y is what? -2. Then how do you find your x-intercept? So we say, okay, x, y is 0, is find your x-intercept. X is 0, find your y-intercept, like your linear equation, right? We did those. So we said y is 0. So what do we do? 0 equals 4 cubed, 4 to the x power -3, right? Y is 0. Then what's your x? What do you think? Plus 3. So 3 is what? 4 to the x power. Then what kind of equations we have? Then we need to find the x. Exponential equations. But we cannot change the base the same. What do we need to do? We said we have to rewrite it as a log, right? What's in the middle? What's outside? So 4 to the x power, right? It's 3. So x is log 4 of 3. Then you need to use base change formula like this, right? So you use your calculator, you find out it's about 0.79. So that's the x-intercept. X is 0.79, y is what? 0, right? So your x-intercept is 0.79 and 0. So you need those, you need to know everything from the chapter 10 before you can answer this question now for your x-intercept. Then we will ask you what kind of asymptotes you have. It's here. So it's a horizontal asymptote, right? Then what's the equation? That's this guy. Y equals -3. So you will have one of those questions on your exam too. Okay? Then definitely we will ask you to graph a log function as well. Then how do we do it? Right? So if we use t-table, but you know for log function, exponential is like this, log function should be something like that, right? So if we use this one, we have what? Y equals log 4 of x. So if we use t-table, we use x, y equals log 4 of x. It's really hard to graph it, right? Cannot see the log. So what do? We always convert the log to exponent, right? Exponent, so that would be what? You do the hook, so it will be 4y equals x. It's the same thing, right? But we use the exponential function to do it. But since y is on the power, so what do? I put a y is 0 instead of x. Otherwise, it's hard to solve. Then 2, -1, -2. We can do this way. So we go backwards because log is backwards of what? Exponents, right? So this one, 4 to the 1 power, 4 to the 0 power. So that would be 1, that would be 4, 16. 4 to the -1 power is 1/4. That was 16, right? So if we do this, what do we have? 1, 2. So what do we have? 1 is 0. That's this point, right? And 4 is 1. 4 is 1. That's this point. Then 16, 12, 2 is somewhere here, right? Then this part, you need to do the fraction part. Otherwise, the picture is not complete, okay? You have quarter and -1. So that's quarter and -1. That's here. Then another one is what? 1/16 -2. So 1/16 for x is tiny and right here. So that will be 1/16 and -2. So your curve will be like that, right? Then this part you need to use arrow as well because it's continuous but never touch it, and it's limited by this line. This line is what? X equals 0, right? So what's your domain? Domain would be for x, left and right, right? 0 to infinity. For the range, go up and down. That would be what? Can't go down forever, can't go up forever. -infinity to infinity. What's your x-intercept? Intercept by x. Oh, here, right? 1, 0. What's your, that's x-intercept. What's your y-intercept? Intercept by y, which is 9, right? So what about the asymptote? The boundary limitation is what? Vertical one. You need to answer is a vertical or horizontal asymptote. The equation is what? X equals 0, right? So it's better for you to print it out, a blank review paper, so you can have a hands-on and follow along. And if somewhere you don't follow right away, you can pause, then, right, think over, do it yourself. That's better, so you have more experience that way when you do the problems. Or you can look at the answer keys, which is with the package for the answer keys for the all the notes and the reviews. It's in there. Either way, but it's better if you can do it yourself at the same time, okay? If we ask you next one, that's the major concepts for this class, right? If we ask you, how would you describe an exponential function? And what's the domain and range in general? Then we will ask you, what is a log function and what's domain and range? That's basic what we are doing, right? So for the exponential function, you will say, it's written this way. it can be, okay, it might shift. It can be written this way as what? For exponential function, if that would be f of x equals what? A base with the exponent, right? Then you need to talk about restriction. B is bigger than 0. We don't use 1. What's your x? X is any real numbers, right? Because you put your x, then you can put anything there. So your graph will look like this. Okay, that's the growth. Then if it's a decay, that will look like this. Then x, if it's a negative x, right? So what's your domain and range? In general, domain is what? All real numbers. For x, range is what? 0 up, 0 down, right? Then what is the log function? Then you will say it can be written as what? That's log function. Function you use f of x instead of use y, right? You have log in there with a base and x. Restriction, same. Right? If you don't write the restrictions, what do you think? You will be deducted points, right? So, and for log, your x is inside the log, then there is restriction, right? So, you need to say inside the log has to be what? Positive number. Because you have to declare what kind of number you are working with, which is your domain, right? So the log functions will look like this in general. So let's see, the domain is what? X, left and right. From 0 to infinity, range will be what? All real numbers, right? So we say in general, log and the exponential functions, they are inverse. That means you switch x and y's. So your range becomes what? Domain. Then domain becomes what? Range. That means you switch your x and y's, right? Okay, we also did what? Composite functions and inverse functions, right? So we will just test everything and to see if you remember all those. So composite function, if I have f of x equals this, I have g of x equals this, right? X for f means you relate x 6 times more minus 5 to y. Then gx means what? You relate x by square plus 3 to y, right? When you stack them up, if you do composite, compose them together. So first you write how you are going to operate, which one you would do first, right? So you would do this one first, g of x with x. Then you will have x squared plus 3 for your f, right? Then f says, I will 6 times it, right? Whatever you have, you will 6 times it and minus 5. Is that right? That's how f will relate whatever put in there, then to give you the y. But you don't leave the answer there, you cleaned up. right? So because it's a polynomial, you need to simplify them, right? Okay. Then for composite function, for inverse function, and we also check if they are one-to-one, right? For inverse function, it has to have one-to-one to have inverse. So how do we tell the graph is a one-to-one function? So first, you have to check for functions first. By doing what? By using, remember, check for function by using the vertical line test, right? Then further to do the one-to-one, then we check for one-to-one by using another one, which is what? Horizontal test. Horizontal line test. Right? We did this. Okay? Then let's see. Let's do it. Is this a one-to-one function? Yes. One-to-one? No. Okay? If this one, is this a function? Yes. One-to-one? Yes. Okay? Then if we have this one, like this, okay? Function? One-to-one? No. Right? That's how we do composite function and check for one-to-one functions. Also, we are going to do inverse functions. Okay, so inverse functions, we might have the graph, we might have the equations for you. So you might do both. So if we have this one, okay, for this one, which one I give to you? Oh, the top one, okay? So we have here, we have 1 point, which is -5 and 0, -5 and 0. And another point is -3 and 2. Okay? Then we have another point is 0, 3. Okay, 0, 3. So another point is 4, 4. 4, 4. Here, 4, 4. So the curve look like here, and here, and here, right? Then for inverse, what do we mean by that? We switch x and y, right? Reverse. So 4, 4 is still 4, 4, 0, 3 become what? 3, 0. -3, 2 becomes what? 2 and -3, right? 2 and -3. -5 and 0 becomes what? -5 and 0 becomes 0, -5. 0 and -5. 0 and -5. Right? Then they should be symmetrical over another side by this line, y equals x, right? So curve like this should be symmetrical to that, so that should be curved this way, then this one should be curved this way, then this one should be this way. So you just do it section by section, okay? So that would be your F inverse, right? So here say, what do we know about graph? A function of the graph, it's inverse, right? How do their domain and range compares? Okay, then the graph for the first one, the graph of the f and f of inverse, right, are reflections because you switch x and y's, right, about the line over this line, y equals x, right? Then let's see the domain for this one, domain and range. Domain for black one, left and right, would be what? From -5 to 4. Range up and down will be what? From 0 to 4, right? For the black line, original one. Then for its inverse, what do we have for domain? Left and right, right? From 0 to 4. From 0 to 4. What's your range? Up and down from -5 to 4. You always write it from smaller number to larger number for the interval notations, right? So that's your range. Take a look. Are they reversed to each other? Of course. This is x, this is y, this is x, this is y. You switch your x and y's, so so you will switch your domain and range for the inverse functions, right? Okay, so for inverse functions, we might have a graph that you have to show, right? What happens if we have this one? We have f of x, we write this 7 over x plus 2, then we ask you to find the inverse function for a equation, right? For the formula style, then you cannot graph, you have to write in the same style, right? So the method we use, we call it what? Switch and solve. Okay, so how should we do? So first, you write it this way, right? Write it as y, then you switch x and y, right? Then third step will be what? Solve it. Solve for y, right? Solve is for y. Y equals something for your function. So what should we do? So we do with times, we say we times the denominator. So we both sides, but I mean both sides times with this, right? So what do we have? Then we will have xy plus 2x equals 7. Then we said you have to solve for y get y by itself. So what do we have? Xy equals what? 7 minus 2x, right? Minus 2x on both sides. Then get y by itself. You divide everything by x. So your y is what? 7x minus 2. So do you leave the answer that way? You will get some deductions, right? Because we say find the f inverse, you need to write the inverse function style. You have to put it back. You have to do it this way. Okay? Then how do we know you are doing right? Then you need to check. Okay? So to check, you need to do two things. Okay, you have to see f inverse f of x go back to x, f inverse go back to x as well. Okay, so only worth 2 points, then you don't need to spend a lot of energies for it and for this class. But if you do it pre-cal, get ready for pre-cal and calculus, you better kind of have an idea what to do for the composite function, right? So how should we write? We should write it this way, right? So we check the first one and second one. So let's do the first one. So what do? We have to do the composite function with it, right? So f inverse, what's your f of x? This guy, right? 7x plus 2. Then what is inverse? Inverse now is this guy, right? Inverse is saying what you have, okay? Whatever you have, you would do what? For inverse, you would do 7 over the x minus 2. That's what it's saying, right? And this guy is 7 over x plus 2 right now. Then what do we have? So for 7 over 7x plus 2, complex fraction, you learned it in 152B class, right? It means 7 divided by 7 over 7 plus 2. It means 7 over 1. Then reciprocal flood. Then what do you have? X plus 2. Right? So this guy is x plus 2 minus this 2. Then you end up with what? X. So f inverse of trivial f, you get back to your x. Okay? Then how about another one? This one, see, we can get back to x as well. So you do f inverse of x, right? So what's your f inverse? So it's this guy, 7x minus 2, right? Then for f, it's saying what you have, then you will do this. Whatever you have, you would do what? 7 over whatever you have and plus 2. Is that what f is doing? Okay, then what you have is 7 over x plus minus 2, right? Then you cancel all this. You have what? 7 over x, which is, you do 7 divided by 7 over x is 7 divided by 7 over x equals 7 over 1 times the reciprocal, right? You end up x. Did we get back? Yes. Okay, that's how we check. Right? Manageable. Now let's solve some equations before we do the apps, right? So we have two types of equations we are solving. One is what? Exponential equation. Another one is what? The log equation, right? So to solve the exponential equations, so one is like those to the x power, right? Like those. Then another one will look like this, right? For the first one, you can see you can make the base the same, you can resolve it. This one you can, then you have to use what? Use the log skills to do that, right? So the method is what? you will try to make the bases the same. Right? Not always possible. Right? And solve. Right? That's how we do. Then otherwise you will do what? You will, like those, you cannot make the base the same. You will rewrite exponential equations as what? As the log equation, equivalent one, right? And solve. Right? So for this one, it's much easier. You can use base 2. So that would be -1. So you need to know what does the negative exponent mean and fraction exponent mean, right? We keep repeating that, and then when we get to your next class, oh, you don't remember. It often's the case, okay? So this one is a -x, this one is, oops, I want to make the same denominator, I mean same base. I keep talking, then I forgot. Right? So that's 3 times 3x minus 1, same base. You can ignore. Then we have -x equals what? 9x minus 3. Then you minus 9x on both sides. So we have -10x equals what? -3. So x is 3/10. Right? And if we have different bases, then we have to rewrite it as a log, right? So we will have what? Log, oops, base what? 5. Which one is inside, which one is outside? So you hook. So you hook here, get inside. So your 2x equals what? Log 5, 7. Then you use calculator to find the value by what? Base change formula to a common log with base 10, right? Then this one, you get the value, it's like 1.2090619. So you use all the decimal, just leave there, right? And then you find it x, you just, whatever the number on your calculator, it sees that your x will be what? It's about 60453. Use as much as you can. Then did he ask you how many decimal points? It didn't. So just give me a few points. Decimal points, you'll be fine. Okay? So we just solved the what? Exponential equations. All right. Then let's solve some log equations. So what's the method for the log? Okay. So first you make one side as what? Simple log. Simplify equations. So it has what? It has only one log on one side, right? On one side of equation. Right? Then you have what? Some log base. This one is x, equals y. Then you can change to exponent. Then exponential equation, then you can just solve like this, right? Then what do? We will rewrite it. rewrite a log equation, right, to an equivalent one, to an equivalent exponential equation and solve it, right? So that's why we wanted you to practice this as well. Say, rewrite this one as one log to get you ready to solve log equations, right? Okay, to write as one log, if the number, you just leave it be, okay? So this one is 2. Because when we solve equations, you can just minus 2 on both sides. So we leave the number alone. Then the rest of them, then we need to write it inside, right? So that will be what? Log 3x plus 2 to the 5th power, right? Minus log base 3 same base x to the 1/4 power, right? Then we want to write as 1 for these 2. If a minus, it means what? You will divide inside. Square to the 5th to the x 1/4 power plus 2. Okay? Or you can write this one as x for the 4th root. But for the computer, you probably don't want to do that. You use this way. But for the test, you can do it either way. Okay? Then next one, if I have a natural log, this one, 5x cubed x minus 4. So we do the opposite. Instead of writing, if you can do this way, you should be able to do another way. So we need to write a what? Individual one. Then inside of the log, it's as simple as possible. Just like x or x plus 2. You cannot be any simpler than that. No powers inside, right? So if it's division, you will what? Rewrite it as separate log by minusing them, right? Then this is as simple as you can be, right? Then, but this one, you have power too many and too many variables. So you have to split them. That's what? 5x to the cube to the half power, right? Then you split them, right? You take half outside. So that would be this one, natural log. And what's inside? 5x cubed, right? Minus this one, right? But you still have too many elements here. So what do? You separate them. If multiply inside means what? You add them individually. Right? And this one is what? This one, actually, it's the same thing as 3 natural log x, right? X cubed inside, you take outside. So make it inside as simple as possible. Then you multiply by half. The final answer would be this one plus that's that times half would be what? 3/2 natural log. Inside would be the simplest one, just x or number, or the x minus 4 is as simple as possible. So that will be your answer. To spread them around and instead of merge to be one single log. This is doing the opposite, right? Then let's see. Let's do some solving log equations by combining to a single log, right? So how should we start? Put it together. If adding, that means inside you need to do what? Multiplying. Right? Now become a single log. Once it becomes a single log on one side of the equation, then you rewrite the log to exponents, right? To solve it. So you do that. So you have what? 3 to the 3 power is this one, right? That means what? 9 equals x squared plus 6x. And now the standard form, you write it in standard form. That would be x plus 6x minus 9 equals 0. Right? Then you split them. That would be, let's see, without work. Oh, no wonder I said, oh, I cannot factor it. Then I got a typo, right? Then that gets too complicated. But for your test, I will usually give you a good number. So that should be 27. So I should minus 27, minus 27. So I should have what? Minus 27 here, right? So 27, I can have a 9 and 3. That would be better. Right? So what's my x? X can be -9 and x can be 3. So remember, we are doing what? Log equations, right? So for log equation to solve equations, remember, need to check, right? Why? Because it's log equations, it has restrictions because the inside the log need to be what? Positive number, right? So can I use a -9? That would be what? Extraneous, right? Then can I use 3? Yes, because the inside the log is positive, so we are okay, right? Remember to do that. Even I do the different colors for you, highlighter for you, and you will still forget, okay? So if we have log 2x equals what? Another example. Okay, so what should we do? If you don't have this one, then you can just compare inside. Both are log 2, right? But if you have extra number, you better move log to one side. Okay, minus log 2x plus 16. Then if you do that, then you one side have a log, another side is a number, right? If one side is a log, another side is a number, then you can rewrite the log to an equivalent exponential equations. Then you can resolve it, right? So for this, if it's subtract, if you rewrite a log, you should have what? Divide inside, right? Should have a division. Then we do the hooking. So you have what? 2 - 1 equals what? X plus 16, right? That means you have half. 2 - 1 is half equals what? X plus 16, right? How do we solve it? You can make the both have same LCD. You multiply this by x plus 16, then you multiply this by what? 2, right? Then you have the same LCD denominator. You can just ignore it. So what do we have? We have x plus 16 equals 2x. Then we solve it, move x over. X is what? 16. Okay, can I circle the answer? you need to check. Yes. Why? Because inside the log is what? Positive. So you can circle the answer. You need to show the reason. You cannot just circle, then you give to me, then you didn't tell me why you can circle that. That means you didn't check. All right? So what do you think? You will get a deduction, right? You have to show the checking as well. So you should be able to solve your log equations, right? And exponential equations, right? You should be fine if you do your part. You do your homework, you keep the learning if you want. That's up to you, right? All right. So let's do some apps. We learned two formulas, right? One is continuous and formula for compounding, right? We have this 1 plus Rn to the nt, right? Another one is what? Continuous, Pe to the Rt. Okay? So for your question, next one, it says if you have $1,283 on a credit card, which charges 14% annual interest, quite a bit, right? And compound monthly, how much will it be on the card if you make no payment for 2 years? They just compounding if they, if they don't close your account. Okay, so let's see. If you use this, because compound what? It's a compounds monthly. So your principal is what? 1283, right? So your annual rate is what? 14%. You change it to decimals. That would be that. Then what's your n? Compound monthly. How many times per year for compounding? 12 times. How many years? Oops, not R, it's T. T is what? 2 years. So what do you have? A equals 1283 times 1 plus 0.14 divided by 12. N is what? 12 and T is 2, right? So you need to plug in your calculator. So if you cannot type in all in one shot, okay, then you do it separately. You do 0.14 divided by 12 plus 1. You will get some kind of number like this. Okay, just keep everything there. Then you take what? Follow order of operations. Okay, then you take 24th power from here, right? Then you multiply. Then when you take a 24th power, you should have something like this. Just keep the numbers, all the decimals there. Then you multiply by this number. Then you end up 94.8 something. Then you round at the end, right? Because it's money, so you do 2 decimal points, right? Don't forget, give me dollar, not the goats, right? You have to tell me what you are working with. It's the money, compounding the money this way. Right? Let's look at the next example. On your page 6, it says, the number of grams of a certain radioactive substance presented at the time t is given by this formula. Y equals y sub 0 kt, right? Looks like this formula, right? T is what? The year, how many years it decays, because for the substance, right? And start from 1 sub 0, then K is what? The growth or decay. So we have K is your indicator. If K is bigger than 0, that would be what? The growth, right? If K is less than 0, that would be the decay, right? So the question is saying, if 200 pounds of this substance is dumped in the Nevada desert, how long will it take for half of it to be gone if it declines at the rate of 0.01% per year? Round your answer to the nearest tenth of a year, right? So we have so many variables. So what's your y sub 0 according to this? It started from 200 pounds, right? Then what's your k, right? We know this one. What's your k? K is what? It says it declines at a rate of 0.01%. So it's negative, okay? Negative 0.01%, so it should be negative, change it to decimals, so it should be this one. So what's your y? We say, do we know the t? Okay, so what's the t? T is what we are going to find. Is say how long it will take. So we don't know. And to get to the half, so what's your y? Eventually, the amount is what? 100 pounds. That's what I mean, right? So you just plug in this number to your formula. So that would be 100 equals what? 200e to the negative 0.0001 t. T is your variable, right? Then to solve t, it's like we keep saying, to solve a situation like this, to be a what? Exponential function, you have to get base and power by itself. So you have to get rid of 200. Often you just get stuck there, okay? So you have to do that first. Becomes 0.5 equals e to the negative what? 001t. So your variable is on the exponents. Then what do? Solve it. You have to change, because you cannot make the base the same, you have to rewrite it as what? A log, right? So you have log base e, then what's inside, what's outside? So hook it, so hook it, so 0.5, negative 0.0001t, right? Then this one actually is what? Your natural log 0.5 base e, right? Then what is your t? Then your t divided by point. So t is what? Natural log 0.5, then negative 0.0001. Then you punch into the calculator, right? Use all the decimals. It's about this one. You divide by this number. That should be what? 6931.5 point, actually 4718. Use all your decimals, right? Somewhere, let me double check this number, make sure it's correct, so you can check when you punch into the calculator. So what's your answer? So it asks you, round your answer to the nearest tenth of a year. So your answer should be what? About 6931.5 years, right? So your exam will be similar to those, not exact, of course, right? But you should be able to, apply it to figure out. Shouldn't be too bad. So the log will be your first problem for this class. You have two problems you need to deal with. You might have issues. One is the log. You should be okay now, right? Another one is the pattern recognition. We are going to talk about that later, okay? So you have to overcome the first problem first for your log, okay? So study and prepare, and you should be okay. Then that will be our review for your exam 2.